going to show you and discuss the types of flow. So first, let's define what is a fluid flow. So a fluid flow is any substances that float or deforms under applied shear stress, or the substances which have the tendency to flow is also called as fluid. So the different types of fluid flows are the steady and non-steady fluid flow, the uniform and non-uniform fluid flow, the rotational and non-rotational fluid flow, and the 1, 2, 3-dimensional fluid flow. And now I will show you the examples of the different types of fluid flow. To classify types of flow, I examine two flow conditions: the uniformity of the flow within the stream and the steadiness of the flow over time. So, flow conditions often change within the same river. So, certain sections of the river or reaches often transition from one type of flow conditions to another and back again. So, while traveling along the river, you may notice a sequence of falls and rapids. These are the areas of different flow conditions. So, if the flow velocity is assumed to have the same speed and direction, so at every point within the fluid, it is said to be a uniform type of flow. So, in my back, you can see it is considered a uniform type of flow. If at a given instant, the velocity is not the same at every point, the flow is non-uniform. So this is an example of non-uniform types of flow. A steady flow. So the main flow parameters do not change with time. Example, as you can see, the water is flowing. It is because of the rain. So as we continue, we can clearly see that the depth and therefore the cross-sectional area are remaining constant. So this gives us a very good indication that the system is in equilibrium, and therefore the discharge and velocity are also not changing with time. So this is a steady flow because the main parameters are not changing with time. However, if the rains stop, so this will now create an unsteady flow, as discharge velocity and area will now change as time goes on. Here, we can clearly see that the depth and therefore the cross-sectional area are dropping as time goes on. So this is now a non-steady type of flow. Rotational and non-rotational type of fluid flow. So, as we all know, rotational type of fluid flow is a type of fluid flow in which the fluid particles, while flowing along the streamline, can also rotate on its own axis. So this is an example of a rotational type of fluid flow in air. So this is a portable swimming pool and air pump. So in the first layer of the portable swimming pool, so as you can see, there is a little air inside. So I will pump air inside this first layer, and the air flows from the air pump to the portable swimming pool, will rotate on its own axis. So as you can see, so the air flows in the first layer of the portable swimming pool, rotates on its own axis in a rotational flow. So this is an example of rotational types of fluid flow. The next is non-rotational type of fluid flow. So in this part of the portable swimming pool is a non-rotational type of fluid flow, in which, as you can see, there are many parts of diamond shapes here. So they are connected with each other. So if I will pump in this part, I will pump an air in this part, without the air flows in this part is considered as non-rotational type of fluid flow. As we all know, non-rotational type of fluid flow is a type of fluid flow in which the fluid particles while flowing along streamline and do not rotate on its own axis. In this part, so the air doesn't rotate on its own axis, but instead it goes in many directions. The air doesn't rotate. So this is an example of non-rotational type of fluid flow. One-dimensional flow is the type of flow in which the flow parameter such as the velocity is a function of time and space coordinate only. So this is an example of a one-dimensional flow. Flow in a pipe is considered one-dimensional flow when variations of pressure and velocity occur along the length of the pipe, but any variation over the cross-section is assumed negligible. The two-dimensional flow. So as we all know, the velocity of flow is a function of two displacement, coordinate, and time. So in this video, so this is the Capayas Dam in Ubay or Papaya Dam in Ubay. So the water flow over a weir is a good example of two-dimensional types of flow. This is the three-dimensional flow. So the velocity of flow is a function of three displacement, coordinate, and time. So as you can see in the video, this is the Capayas Dam in Ubay, the largest dam found in Ubay, which supports the irrigation of the crop yields here in Ubay. So this is an example of three-dimensional types of fluid flow. So as you can see, yes, they release the water to support the irrigation of many crop yields here in Ubay. And that is the Capayas Dam.